Hey guys, welcome back. Today we're going to continue introducing functions. So yesterday we took a look at graphs and we determined what made them functions. We used something called the vertical line test to check whether or not some inputs had more than one output. But graphs aren't the only type of relationship that can be considered functions. And in fact, we don't always have to worry about mathematical relationships. We can look at any type of relationship and determine whether or not it's a function. So let's take, for instance, a bakery. Let's pretend this big machine is some type of function. And when I put something in, I should be able to get something specific out. So our input is going to be this apple. Let's put the apple through the machine and see what we get out. We get out apple pie. What about if we had blueberries as our input? Let's put it into our function machine, and this time we get out a muffin. What about some cherries? Cherries are our input, put it through the machine, and this time we get out a pie again. Is that okay? Well, we can use mapping to determine whether something is or is not a function. When we use mapping, we take a look at all the input values and see where they match up on the output value side. So for instance, our apple, that became a pie. Our blueberries became a muffin, and our cherries also became a pie. That is okay. This is a function because each input value, or in this case, our fruits, lead to exactly one output value, which would be our baked goods. Well, if that's okay, what would be a problem? Let's say we take our apple again and we put it back into the machine. If we put it back into the same exact machine, then we would expect to get out the same exact thing. But in this case, we got out juice. Something's not right with this machine. So if we look back at our mapping, now we see that our apple is not just leading to an output of pie, but our apple is also leading to an output of juice. And that makes this relationship not a function because some inputs are leading to more than one output. So this is an example that's not really very mathematical, but let's go back to a little bit of math. Let's say that we're inputting the number 5 into our function machine, and our function machine is the equation y equals 2x plus 1. So if I put 5 into that function, I get out 11. If I put in negative 3 into this function, I get out negative 5. What if we put in 9? What will we get out? We get out 19. So how do we observe this through mapping? So again, here are all the input values that we used. We put 5, negative 3, and 9 into the machine. What did we get out? Well, when we put in 5, we got out 11. When we put in negative 3, we got out negative 5. And when we put in 9, we got out 19. So is this a function? It is, because again, every input on this side leads to exactly one output on this side. Now, what about if we want to look at it as a table? Mrs. Wesley is going to take us the rest of the way.
So far, we have looked at graphs and maps to try and determine if they are functions or not. Now we're going to look at tables. Using the equation from before, y equals 2x plus 1, I have now included all of their input and output values in this table. So all of the input values are in the x column, and all of the output values are in the y column. Now, what if I added a new input? So let's try and add negative 10. So I'm going to add negative 10 into the x column. But now how do I determine the y value or my output? As long as we know the x, we can always find the y by plugging in. So I'm going to replace negative 10 with the x value in the equation. When I multiply 2 times negative 10 together, I get negative 20. Plus 1 is negative 19. So that means the output value when the input value is negative 10 is negative 19. So this table represents a function because every input, in this case 5, negative 3, 9, and negative 10, have their own respective output value. Only one output value matches with each input. And not only is this a function, but this is a linear function. Now, what if I looked at an equation? So is this equation a function? Do we think y equals x squared is a function? Well, if we weren't sure, we can always make a table for this equation. So we're going to figure this out by testing out some inputs and outputs. So here I have the inputs of negative 2, 0, 2, and 4. And how do we figure out the output values? That's right, we're going to plug them into our equation. So when I plug in negative 2 into the equation y equals x squared, I get the answer of 4. Then if I try it with 0, I get the answer of 0. So I'm going to add that to my table. Then if I try it with 2, 2 squared is also 4. So I'm going to add that to my table. And then if I plug in 4, I get the answer of 16. So now looking at this table, do we think it's a function? The answer is yes. This table represents a function because each input value has its own output value. And it's okay for 2 different inputs to have the same output. It is not okay for the same inputs to have 2 different outputs. Think about Jenny. When Jenny was working on her skyscraper, when she was going up the ladder, she was at 20 feet from 10 to 20 seconds. So it's possible for you to be in one location for an extended period of time. Just like here, it's possible to plug in 2 different inputs and be at the same output. So this is a function. And let's say you weren't sure again. If we look at our graph to make it definitive, here we have the parabola this equation is creating. So when I go through my parabola, if I were to do the vertical line test, the vertical line would go through each point only one time. Therefore, it passes the vertical line test. And if you wanted to see here, at negative 2, we're at 4, and positive 2, we are at 4. And again, that's okay to be at the same location at 2 different times, because that means that each input still only has their own output. And specifically, this is a quadratic equation. Now, if we wanted to try another equation, we have y equals the square root of x. So here's my input of 9. I'm going to plug 9 in. And we know that there's going to be 2 answers to this. When we take the square root of 9, we have the answer of 3 and negative 3. So now if I add that in to my table, and I want to decide, do we think this is a function that when the input is 9, its output is 3 and negative 3? No. This does not represent a function because here the same input gave you 2 different outputs. So here the input of 9 leads you to those 2 different outputs. And here we see the mapping of it to help prove it as well. Now, what about this table? Is this table a function? Yes, this relationship is a function because each input, x value, leads to only one output, y value. So for example, if I asked you if the input is 3, what's the output? You would say 80. When the input is 3, the output is 80, and that is the same for each of the other inputs. There's only one output. How about this table? Is this table a function? No. This relationship is not a function because some inputs, x values, lead to more than one output, y value. So for example, I could ask you, what is the output when the input is 2? Some people could say 5, some people could say 7, some people could say 9. And that's because this input of 2 has multiple outputs, which is not allowed and makes this table not a function. So now it's your turn. If you turn to page 95B in your notebook, copy each of these tables down and determine if the table is a function or not. Great job today, guys, and good luck.